Welcome to the next lesson in electrostatics. We are going to discuss electric field strength, and we are embarking on calculations that are involved in electrostatics. I assume you already know the basics, the definitions and the expressions, but to remind you, electric field strength is the same as the force per unit positive charge. We have example number 1, which says that calculate the electric field between the charged plates. One plate is kept at a potential of 0.20 kilovolts and another is earthed, and also they are separated by a distance of 5 millimeters. Separated by a distance of 5 millimeters, we have one plate and another plate. One plate, the lower one, let's say, is earthed, and then the upper plate is kept at 0.20 kilovolts. The separation between the plates is 5 millimeters. So from the definition of E between plates is the same as the potential difference over the separation between the plates. So that means that the electric field intensity would be 0.2 kilovolts divided by the separation between the plates, and that's 5 millimeters. Change it to meters. This is going to give us something like 40,000 volts per meter, which you can write as 40 kilovolts per meter. We have example 2. A single electron is accelerated from rest in a constant electric field of 1000 Newton per coulomb through a distance of 3 centimeters. Find the electric force on the electron and calculate also the final velocity of the electron. We are given the mass of the electron as this, that's a constant, or is given, okay, we are given the electric field intensity as 1000 Newton per coulomb. Remember from definition, electric field intensity is the same as force per unit charge, so that's the unit. Distance is 3 centimeters, which is 0.03 meters. You change that straight away. So what we are interested in is to find the electric force on the electron. So recall that the electric field intensity is force per unit charge. Therefore, in this case, F is going to be E times charge. And since we are dealing with an electron, we know the charge of that electron. This is going to be E given as 1000 times charge over one electron, which is times 10 to the power negative 19 coulombs. This is going to give us 1.6 times 10 to the power negative 16 newtons. Very small force. Very small. That's not what we want. That's not all. The next part is saying find the final velocity. Look at the question. It's a single electron accelerated from rest. This gives us the initial velocity is 0 meter per second. Initial velocity is 0 meter per second. And we have already the force that causes that acceleration. And we know that force is always equal to mass times acceleration. Therefore, acceleration now caused by that force is going to be 1.6 exponent negative 16 divided by the mass of an electron given as a constant 9.1 times 10 to the power negative 31. This one, if you feed in your calculator, you're going to get 1.76 times 10 to the power 14 meters per second squared. Quite a very big acceleration. And since we know that this motion of an electron is an accelerated motion, and then the field is a constant electric field according to the question, it means that this acceleration is going to be taken as a constant acceleration. Therefore, we are free to use the equations of uniformly accelerated motion to get the final velocity. We shall not use any of the equations that involve time because we don't have it, but the most appropriate equation is v squared equal to u squared plus 2as. So we have seen that this one is 0 according to the question. We have everything else. So we shall have v equal to the square root of 2as. So v is going to be 2 times acceleration, which is 1.76 times 10 to the power negative, power positive 14, multiplied by the distance, which we changed already in meters, 0.03. Let's say that's still squared, we have no space, then v is going to be the square root of all that. If you feed in clearly in your calculator, you get 3.2 times 10 to the power 6 meter per second. So we've answered the question very well, and the answer was correct. And that's the velocity as 3.2 times 10 to the power 6 meter per second.